This first example of simplifying radicals is number 1 on your homework. In class we practiced a lot changing rational exponents into radical form. For this particular problem it's best to work the other way around. So I'm given a radical and the first thing I'm going to want to do is put it in rational exponent form. So I'm going to take the base, the exponent becomes the numerator, and the index, remember index is what's in the little hook, the index is going to become the denominator, and I'm going to do this for both of my radicals. Now the problem becomes a lot easier because 8 over 4 is just 2, and 6 over 3 is also just 2. So I really have the quantity 2x squared times the quantity 2x squared. If I simplify each of these separately, I get 4x squared times 4x squared. And when I multiply those, we get 16x to the 4th. This next one is problem 6 on your homework. It's the quantity 16x cubed to the power of 3/2. There are lots of different ways that we can work this one. The first way that I'm going to do it is I'm just going to take my exponent and I'm going to apply it to both parts of the term that is the base. So it's going to be 16 to the 3/2 power times x to the, and remember if we have a power of a power, we end up multiplying, so 3 times 3 over 2 power. That's just 16 to the 3/2 times x to the 9 over 2. And then 16 is just a regular old number. If I think about what it really means to have a 3/2 power, if I think about this in radical form, we have the square root of 16 cubed times, and I still have x to the 9 over 2. I'll go ahead and rewrite this one as a radical also. So I have x to the 9th underneath the radical. 16, the square root of 16 is 4. So I really have 4 cubed times the square root of x to the 9th. And thinking about that further, 4 cubed is 64. So I fixed 64 times the square root of x to the 9th power. Let me shrink this down a bit. Get some more space. So I've got 16 times the square root of x to the 9th. This is where I'm going to start thinking about simplifying the square root of x to the 9th. And because my index is 2, I've got a square root here, I want to separate x to the 9th into little x squares, as many as I can get under there. So far I've got 2, 4, 6, 8, and the last one has got to be a single x. Okay, and just counting again, if I'm thinking about counting my exponents, I've got 2, 4, 6, 8 plus 1 makes 9. That's still equal to my original x to the 9th. So I really have 64 times the square root of x squared 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 times the square root of x. Okay. And once I get used to this, I'm certainly not going to have to show all this work, but until then, this is a good way to think about it. So I've got 64. The square root of x squared is a plain x, so I've got 4x to the first powers, and then I've got the square root of x that can't be simplified away. So my final answer here is 64x to the 4th times the square root of x. This example deals with a negative exponent, so that's why I picked this one. The very first thing I'm going to do is take care of that negative exponent. Remember, if we have negative exponents, what that really means is that what we really have is 25 to the positive 7 over 4 power, but it's in the denominator of the fraction. So again, if you have a negative exponent, you flip the base. So the base was originally a whole number. It's now going to become the denominator of the fraction. And you turn the exponent into a positive. Once I have this, I've got the rule that tells me if I have the same bases with different exponents and we're dividing, that I can simplify them by subtracting the exponents. So I'm going to do my little thought bubble over here. I've got 1/4 minus 7/4. That's going to be negative 6/4, which is negative 3/2. So I've really got, this is really equal to 25 to the negative 3/2 power. Okay, and again, I wound up with a negative exponent for a second time. First, I'm going to rewrite this, making that exponent positive. So I've got positive 3/2. And then I'm going to think about it as a radical instead. So I've got the square root of 25 cubed, making this just a little bit smaller. The square root of 25 is 5, so I really have 1/5 cubed. 5 cubed is 125. Okay, I chose this one just because it looks a lot more intimidating than it really is. The very first thing I'm going to do is take this exponent and apply it to both parts of the base that I have here. So I'm going to do negative 8 to the 2/3 power times x to the 18 times 2/3 power. And for now, I'll just keep the rest of this the same. Just tackle it one piece at a time. And if I look, 18 times 2 divided by 3 can be simplified to 12. So I have x to the 12th. And I've still got my negative 8 to the 2/3. And I still have my cube root of y to the 6th over here. Okay, now I'm going to start tackling my exponents. I'm going to rewrite this as negative 8, the cube root of negative 8 squared times x to the 12th times, and then I'm actually going to rewrite this one, this last one, as a fractional exponent. So I'm going to do y to the 6/3. And I'm doing that because 6 divided by 3 is 2, so already that part of the problem is going to get much easier. So on the next line, I for sure have x to the 12th times y squared. And now when I look at this part, I want to remember a couple things. I want to remember that if it's a cube root, a negative underneath the cube root is okay. And the reason is if I take something and multiply it times itself 3 times, I should be looking to get negative 8 here if I'm talking about a cube root. And if I put negative 2's in the slot, negative 2 times negative 2 gives us positive 4. Positive 4 times negative 2 is negative 8. So it works out. It's different than when you have square roots. So this is really equal to negative 2 squared times x to the 12th y squared. And now negative 2 squared is positive 4, so I have positive 4 x to the 12th y squared.